Okay, question 70. Which of the following graphs describe how the volume of the gas sample changes with temperature? Volume and temperature, they both go up and down together. So we know that that's directly proportional. And this is what the graph would look like. So, if one goes up, then the other goes up. So we get a straight line graph like this. Okay, the other situation, if you had it inversely proportional, it would look like this one. Okay, so the answer is A. Okay, which of the following is the pressure of a gas sample the greatest? So you want the greatest pressure. Well, you want higher temperatures because higher temperature will make everything bounce around a lot harder and faster. And we want to squeeze the gas down to get higher pressure. So we want high temperature, low pressure, low volume. So higher temperature, I would eliminate the 20s. And then of those other two, I want the lowest volume, so I want the 1.5 rather than the 3.0 liters. Okay, 72. If the volume of a gas at 323 is changed from 780 to 620 at constant pressure, what will the new temperature of the gas be? So we have volume, we have temperature, so we're going to do V over T equals V over T, and I substitute my numbers, so 780 over 323 is equal to 620 over X, and I would cross multiply to get my value of X, and I end up with 257. Now just looking at this, if my volume gets smaller, that means I must be cooling down my gas. So if I'm cooling it down, looking for an answer that is smaller than 323, so I can eliminate answer B and eliminate answer D, okay, and then just calculate and try to find which one it is. For 73, okay, again, I've eliminated a couple of answers. A sample of a gas with a volume of 700 milliliters and a pressure of 1 atmosphere is brought to a volume of 200 milliliters. So what I'm doing is taking my volumes, making it smaller. So if I squeeze my gas, I know my pressure gets greater, and the law is PV equals PV. So I can either substitute things in and calculate, but I can look at this and say, okay, my volume is going from 700 to 200. It's going 3.5 times smaller. So my pressure is going to be 3.5 times larger. So certainly my pressure, I can eliminate 1 and C, A and C, because those are the same pressure and smaller pressure. I know it's going to be higher. So 3.5 is the good answer. Oops. Okay, up here for 74. Okay, a constant volume pressure of 97.3, 275 Kelvin undergoes a change in pressure too. So I have two pressures and I have a temperature. So that's P over T equals P over T. Okay, I can set it up. So 973 over 275 equals 104 over X. But again, if I say my pressure is getting larger, then my temperature must be getting larger. I need an answer that's larger than 275, and there's only one answer that's larger than 275, so it has to be answer D. Okay, for 75, it says a gas, blah, 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 at STP. Okay, at STP, now that implies two values. That implies that the pressure now is 760. I'm going to keep 760 because my other pressure is 680 mmHgs. And my temperature in Kelvin is 273. This one I had to change. It's 25 degrees, so I changed that to 298 Kelvin before I had a chance to forget. And now I just start substituting everything in. And so PV over T is PV over T. Just keep the right numbers together. And just to save time, I left off all my units. So here's my substitution. And then I solve for X. And I got 282.787. So that's 283. For 76, okay, 1.22 liters of a gas at 298 Kelvin, 750 mmHg. So I've got a volume, I've got a temperature, and I've got a pressure. Undergoes a change in pressure and temperature, so I have a new temperature, I have a new pressure, what's the new volume? So that really sounds like PV over T equals PV over T. Again, I substitute in the numbers, and there's not a lot of conversions to do, and I just solve for X. X, I got 1.3968, 1.40 liters. Okay, last few problems. 77, what volume will 27.6 grams? Okay, if I'm getting grams, this is probably PV equals nRT problem, okay, because I'm going to do moles and things like that. Okay, so what volume would 27.6 grams of SO2 occupy at a pressure of 97.3 kilopascals and a temperature of 38 degrees Celsius, and the molar mass were given? Well, there's an awful lot, it would be nice if I had more room, an awful lot of conversions to do. If I want to do PV equals nRT, my temperature has to be Kelvin, so 38 turns into 311 Kelvin. I made a mistake when I first did it. And the pressure has to be in atmospheres. Okay, so I had to change 97.3 kilopascals divided by 101.3, and I got 0.9605 atmospheres. And I have grams. I'm going to change grams into moles. And when I do that, then I got, where'd it go? There it is. Okay, 27.6. First time I wrote it down, I wrote 26.7, so be careful. And here's the molar mass, so I got that many moles, 0.430. So I want my volume, so PV equals nRT, so therefore V equals nRT over P, and I just substitute in my moles, my R, my temperature in Kelvin, and divide by the pressure in atmospheres, and I got 11.44 liters, which is answer D. Okay, number 78. Okay, a 240 milliliter sample of gas at 100 degrees Celsius, change it to Kelvin, 373, and 755 mmHgs, okay, is found to have a mass, okay, if I'm talking about mass, that's probably PV because nRT, mass of 1.12 grams. What is the molar mass? Okay, well, molar mass, we know, is going to be grams over moles. They're telling me grams. If I can find moles, which sounds like PV equals nRT, then I can solve the problem. So PV equals nRT. So my pressure here has to be in atmospheres, so I convert my 755 to 0.9934 atmospheres. Convert my volume to liters, just move the decimal point, so 0.240 liters. And my temperature has to be Kelvin anyway, so 373 Kelvin. So PV equals nRT, N equals PV over RT. Substitute in my values, I get 0.0077856 moles. So 1.12 grams is to 0.007785 moles, as 143.855 grams is to 1 mole. And that rounds off to 144 grams per mole. Answer D. Now the last problem here, I almost thought that was PV equals nRT, especially since R is given. And that's true. You can do this with PV equals nRT, how many moles, that would be a big clue. But since it is at STP, I can just use 22.4 liters per mole. So 1 liter times 22.4 liters per mole equals 0.04464, which is answer A. The reason this is also PV equals nRT is because that's where we got our value of R, is by using all the data, 22.4 liters for 1 mole at STP, and that's where we get 0.0821. So this works either way. And that's the entire practice test.